You guys are really missing out on some great music. All those Sun songs that I had all queued up and everything, but we're in a hurry, so I'm not going to bother you with showing you my ugly grill or playing music or whatever. Today, this video is about geothermal energy, and we start on page 361. Geo, the word geo means earth. Thermal means heat, so this is heat from the earth, and we try to use it to our advantage any way we can. Once again, this is an energy source that's supplementary. It's not necessarily the way that we're going to get all of the electricity that we need, but it's certainly something that can contribute to the grid, and that's what we're talking about here. All right, water is heated, better fix that, by molten rock. Geysers, hot springs, stuff like that you see here in and around the United States, like at Yellowstone National Park. That hot groundwater does not naturally rise to the surface, but if you drill for it, you might be able to access it. In addition, we have these things called geothermal vents. These are actual gouges in the Earth's crust that are they're thin, but they are deep. And because they're deep, that heat comes up through those cracks in the form of steam. In some cases, they're very, very hot steam. You know, these hot springs that you see that have popped up around the United States are very therapeutic, and people go there on vacation. Those things aren't so hot you can't stand them. They're hot, but 110, kind of like a sauna or a jacuzzi, something like that. But hey, if you've got to boil water to 212 degrees in order to make the steam that turns a turbine, that turns a ball of wire inside a magnet, then why not heat up water that's already halfway there at 110 or 120? So that's the idea of geothermal. The problem is, if there's a geothermal vent in California, we can't use it for our electricity, so it's very localized. In some locations, for instance in Iceland, they harness the steam that comes from these geothermal vents, and they send it to radiators in people's houses, and that's how they heat their homes. In fact, I think the book says something like 89, 90, something like that % of all of the homes in, 87% of the homes in Iceland are heated by geothermal vents. But we can also use the heat, the steam that comes out of these vents to turn the turbine that turns a ball of wire inside a magnet, and therefore produce, look at these spelling errors, electricity. In Iceland, they get 20% of their electricity from geothermal vents. We're pretty busy when it comes to geothermal ourselves. There are several states that have these vents available to them. Hawaii, it's a volcanic island. Nevada, California have these geothermal vents. So you build a power plant right on top of the vent, and you take that steam to make electricity. This is considered completely renewable, or maybe you could even say non-depletable. One of these days, if any of these vents stops producing heat, stops producing steam, then we're going to worry about it. But right now, that's not happening. And there is a third way that we can use geothermal energy, and that's not from a vent, but just the idea that the ground holds heat better than the air does. So we can use the sun's rays warming the ground, put a heat pump in there, and warm a house that way. And I've got a diagram to show you about that. Okay, right now let's see how California is using geothermal energy to make electricity.
Welcome to one of Cal Energy's geothermal power plants. Unlike other power plants that rely on coal or other fossil fuels to create electricity for homes and businesses, geothermal power plants use superheated fluids from the Earth's geothermal resources to generate electricity. The natural heat of the Earth creates geothermal resources. This heat comes from molten rock called magma, located at the Earth's core, deep below the geothermal resource. Over thousands of years, rainwater seeps through cracks in the Earth's surface and collects in underground reservoirs. The magma heats the water until it becomes a superheated fluid. To reach the superheated fluid, wells are drilled 5,000 to 10,000 feet below the surface of the Earth. These wells, called production wells, bring the superheated fluid to the Earth's surface, where it can be used to generate electricity for homes and businesses.
All right, so there you have it. That's how Cal Energy, they're actually drilling down in areas that have the superheated water and pumping it out of the earth. But most of our geothermal steam to produce electricity buildings are actually found on top of geothermal vents. This diagram shows you how it works, where they drill down and down far enough to get the superheated fluids. It comes up in the form of steam and hot water. Of course, they have to sort of filter that, so the brine is what's left behind, but then the warm water can go across the turbine and generate electricity that way. One of the things that they're trying to do to make sure that this is indeed renewable is to put cooled water back down into the impermeable rock and let the magma that's way down here continue to heat water again. So they're trying to replace the water in order to make it completely renewable. All right, this is how the ground source heat pump works. And you can see they use circulating fluids here. And the heat's taken off the house from a heat exchanger. And the fluid expands and cools, becomes a gas that's much cooler in the ground. That's here. And of course then the warmer ground heats the cool fluid, makes it nice and warm, and then that warm, that heat is eventually pumped up into the house and goes through a heat exchanger, a radiator of sorts, and then that's enough to heat a room. Or in this case, it's enough to heat a house. Again, this can only happen at places where you've got this superheated fluid down here, deep down, way below where the groundwater is, to access the heat that way. It's not applicable in a lot of places around the world. But where it is applicable, let's use it. Take advantage of it. And here's the statistics. Here is the places in the world where we have geothermal vents. Iceland is a big place that's got a lot of it. You can see here in California and here in the Baja Peninsula of Mexico. Look at the vents along the Andes Mountains. Lots of those for South America. And up here in Alaska there are some opportunities as well. And a few others. Russia has some also. In fact, let's see here. It says where in the world we do the most of this. The United States does produce energy from geothermal. In fact, it's the third largest renewable energy after hydro and after biomass. The key places in the world that use geothermal vents to augment their electricity is the United States, China, and Iceland. Here's the pros and cons. And once again, you should be building in your mind a table that has all of these pros and cons, sort of like something that you can access later on, because you ought to know what's good and bad about all of these. Now, there are some fossil fuel emissions associated with this because you have to run the turbine and all that stuff, but it's much lower than obviously coal or any of those other things. It's low cost after you build the factory. After you build the power plant on top of the vent, it's pretty low cost, because you're not spending any money for the fuel. The fuel is superheated liquid coming up out of the vent. Low land use because you only have the power plant right there where the vent is. There is some environmental impact though, because after all, you still have to use some carbon dioxide. There are not a lot of places in the world that have this. We are worried that it will be depleted, although again, as I said before, no vent has stopped making steam. Well, that superheated fluid that comes out of the earth can have other elements associated with it, and one of the elements that is associated with it is sulfur. And hydrogen sulfide is that rotten egg smell. And so that's where this brine comes into play. This is where they filter those other elements that are in the water so that the water's clean when we run it across the turbine and make electricity. So it can be odorous. Now, how's that for a short video? I ought to go right into wind right now, but I know wind is a super long one, so I'm not going to do that. This was a nice short video for you, geothermal energy. See you later.